Hi, good afternoon, students. Welcome to the 2020 H3 Chemistry Workshop on Literature Appreciation. We'll just wait for another 1 or 2 minutes for people to come in, but while waiting, could you kindly refer to the following slides where you can actually download some of the articles that we are going to discuss today. I will also be uploading my slides later on so that over the weekends you can download and maybe refer to it as and when necessary. If you prefer QR codes, you can just scan using your phone and then get access to a Google Drive as well. Yeah, so we'll just probably wait for another half a minute. Okay, welcome once again. I think most of the people are in. We have slightly above 70 plus students and teachers from over 7 JCs. So once again, welcome to our workshop this year, despite the COVID-19 pandemic. I think we are very happy that a lot of you are still signing up for this particular workshop. I think first of all you must congratulate yourself for showing resilience in continuing to take this very demanding subject. So I think you should give yourself a pat at your back, or even buy yourself a small treat tonight. Yeah, because I think H3 Chem is really a very interesting subject, and I'm sure you have gained a lot from it. And I hope that for today's session you will gain a lot more as well, and to really understand what exactly is research about. Maybe not entirely about research, but how do stuff that you get to learn end up as a textbook knowledge. But before we move on, I would like to invite our principal consultant 2 for science, or otherwise known as our head of chemistry in Hwa Chong, Dr. Benjamin Chan, to give us a opening address. Dr. Chan, please.
Dear students and teachers, let me extend a warm welcome to you to this Literature Appreciation Workshop. When I look outside my window now, I see it's raining and gloomy. But somehow when I see so many of you on screen, it does make me happy. Let me also thank your teachers, Mr. Wee and Mr. Lee, for organizing and supporting this workshop. To me, scientific literature refers to publications of the work of scientists. It comes in the form of science magazines, science journals, newsletters, and articles, and so on. As these are reports of ongoing or completed research, they serve to inform society of the impact of science to our lives. For example, today I read from the papers reports of Singapore's mass test kits for COVID-19. We want to pay attention to these reports to see how the test kits can help to ease our current reality, which is the COVID-19. Quoting the writer C.S. Lewis, literature not only describes reality, but also adds to it. That's why scientific literature is so important to us. So I wish you a fruitful and meaningful workshop, and that you find it challenging and rewarding as you dwell deeper into scientific literature. Thank you.
All right. Thank you, Dr. Chan, for the interesting opening address. We would like to thank him once again because amidst his very busy schedule, he still took time off to actually grace this particular occasion. Right. So, without further ado, I will just move on to what I want to cover with you guys today. So, so if you look at the timeline, we are I think it's about 16:11 now. Pretty much we are done with a little bit of the introduction. For the next 15 minutes or so, we'll be discussing, I'll just be sharing with you, not exactly discussing, but just be sharing with you some of the nuts and bolts of literature, and where can you potentially source them, and what can you do about when you look at them. Okay, you'll not, but rest assured that you'll not just be 15 minutes of me talking and talking and talking, but I will give you a little bit of time to do a bit of reflections here and there. We will go for a short break at about 10 minutes. Yep, so during this break, if you have questions, just feel free to ask me. I think the chat function has been disabled, so I would appreciate if you can just switch on your mic, and then yeah, just ask, and then let me know where you're from. And then about 5:10 onwards, we'll do a bit of discussion on one of the article. Yep, it's labeled as article 2. Yeah, tell you a little bit more about it later on, and then hopefully at about 45 we can do I can get 1 or 2 groups to do some presentation. Yeah, but don't worry about it, I'm not going to rush through the whole thing. If we can't meet the schedule, it's perfectly fine, because whatever we can't finish, I can always do some recording, and then you guys can view the videos as and when they are ready. Okay, so yeah, just sit back and relax. I don't intend to rush through. Okay, maybe I can do a little bit of self-introduction. I've been teaching H3 since 2011. Probably I won't go too much into details, but quite a bit of the curriculum that Hwa Chong is having, and as well as some of the collaboration we have from a lot of other schools, and indirectly you guys are part of it, so you're kind of like getting some of these interesting ideas, and for example a workshop like this. Okay, so been doing a lot of collaborative work. Okay, so I have also quite a number of interesting experience to share throughout my 11 years in education. Perhaps one of those you can see from the photo there is me. Actually, two months ago, I was actually in La Trobe University in Melbourne doing a sabbatical there. Yep. So those 4 are my 4th year students. Actually, they are honor student in La Trobe. I've taught them a full course in photochemistry. Yeah. So when chance arise, I will do some sharing of that. And maybe you guys can benefit as well as one of the optional topics. Okay. Yep. So I will just go straight into the next part. Would you like to make a guess, like when's the earliest publications for science? Yep. I mean, just pop up the numbers. I mean, if you can, just turn on the mic and then say something like, when's the earliest publication? Yep. So maybe give a half a minute to think through. Yeah, some of you might be thinking about maybe 5,000 years ago, like prehistoric man writing the hieroglyphics on the walls, or even like when Shakespeare was born, or the famous Chinese literature, those era thousands of years ago. Actually, it's not really correct. Okay, you'll be surprised. The first known publication is actually 1665. Okay, that's just slightly above 350 years ago. Yep. Okay, so well, I mean, you might be surprised. You might be thinking, is it because of the limitation of technology, etc.? Well, I would say that science as a discipline didn't actually exist for more than 400 years. In fact, not more than 350 years. Okay, if you look at this very interesting word above, it's written as philosophical. Okay, so if you read into history, most of the famous people, if you look at how the world how civilization actually started, and then how the key stable civilization actually rose into the different segments such as kingdoms. I mean, in Japan you have the Meiji era, you have all the warlords, etc. Right? It all begins with some form of a culture related to literature, for example. Yeah, so in the past, if you are a learned person, you're a cultured person, then you do a lot of writing, you do a lot of poetry, you appreciate nature a lot, you do drawings, yeah, and you go through a lot of philosophical thinking. Yeah, so that's what people normally do many hundreds of years ago, and to some extent how they rose up in the society in terms of their status, right? If you watch about those very those shows depicting the different eras in the ancients, in the 1500s 1400s, right? Yeah, or even in fact even all the way to like 18 1900s, right? This is what you realize. Yeah, people don't really study science. In fact, the word science don't really exist. It used to be called natural philosophy. Yeah, for a while, because people write down on what they observe, like the sun, the moon, and we thought it's some form of philosophy. Then after a while, like it got branched out, and that where you get physical science, and then slowly it become physics and chemistry. Biology don't exist for a very long time. In fact, physics and chemistry has a much longer history than biology. Yeah, so pretty much that's how people come about. And you might have also read about in a long time ago, scientists like Galileo, all this, they got prosecuted because they went against the conventional belief that the Earth is the center of the universe. Yeah, you know that kind of ideas that you have read about, maybe sometimes even your GP. Yeah, like you learn about the history of science. Those of you taking KI, you might delve a lot more into that. Yeah, so actually science don't really have a very high reputation in the past. Not because it's not important, but because mankind, I think, in terms of the mind, the brain, and the discovery, it's still slowly being uncovered. Okay, so yeah, so then what exactly make up a publication? So basically people write in to tell, to just share that, oh, they have discovered something, and then people can debate about it, and if you don't agree, you write something else to tell me that, okay, you have other evidences to show that what I have written is not true or is not correct. Yeah, so that's how the ding dong here and there lah. Yeah, so it went on for the next couple of hundred years, and then until now, that's how knowledge is being formed over time. Okay, in fact, a lot of the reactions that you learn in H2 and H3, they have been around for like 100 over years. Yeah, of course there are improvements being made, but the fundamental remains the same. Okay, then of course, I think I've just given you a little bit of a clue into this question. Have you ever thought about the origin of the stuff you have learned? Like, where do they actually come from? Is it like philosophers think about it, or like what the common myth said, Newton sit under the tree and then suddenly, you thought of it, okay, so this is how things are being invented. But science is not exactly an invention, right? It's like a discovery of things. So for example, like for example, the things you have learned in chemistry, like SN2. How do you know that for SN2 it must be a rear attack? How do you know that SN1 it must go through a carbocationic intermediate? How do they know all these things exist? Yeah. So if you look at it, all the basic physical organic chemistry that you have learned, how do you know that the Hammond postulate is true? Who is Hammond? What about the Bell-Evans-Polanyi principle? Like, who are these three people? Yeah. So what exactly is kinetic control and thermodynamic control in the study of reaction mechanisms? Like what are they? Yeah. But if you really look harder into them, right, you realize that the thing about chemistry that kind of like bewildered a lot of people, right? It is that it's not a discipline that normal people can relate to in everyday life. So for example, if you look all around you lah, uh, everyday objects lah, for example, cars, locomotives, right? How the car moves. Uh, there's a competition between China and Japan for the faster and the most efficient bullet train, high-speed rail, right? So you see all this in the news or even TV. Like in the like 10 years ago, people talk about plasma TV. Now they talk about OLED TV. You know what are they? You know, so it seems that material science, it seems that physics, kind of like relate a little bit more to your everyday life. I hope that makes sense. For example, when you look at waves, you will think about, okay, it's influenced by the gravity from the moon, or maybe you read about it even before you learn how to do titration. I suppose, um, or you might be thinking along the line that you know what, when a car goes in a certain direction, what is the amount of force it needs to hit the object before the airbag inflates. Like things like that. It seems that physics relates more to everyday life. Materials as well, like we all look at handphones, we want to build that thinnest phone, so we want to make the CPU as thin as possible. Yeah. We are always looking out for improvement on aesthetics or on things. Yeah, but people normally don't talk about like things in chemistry that you have learned in your how is being related to everyday life. Maybe very few incidents people will remember, but definitely not your generation. For example, 0708, there was this melamine. If you dig into newspaper, you realize there's this melamine case in China where the milk powder manufacturer actually artificially inflate the nitrogen content by adding this starting material for polymer known as melamine. Yeah, something along that way. So something along that line. Yeah. So that's where chemistry become, oh, so melamine. But it's not exactly chemistry, you see, because that's food safety. That's not like a reaction. Like people don't normally talk about it. When people talk about the latest drug for COVID, yeah, they talk about a vaccine, right? And then you might heard of some HIV drugs being used to treat COVID-19 patients, and with quite a bit of success. Yeah, but that's all you heard about it from the media. You don't hear people saying, this particular drug is being made through a semi-synthetic strategy. Like when you write about these things, people just get turned off. What semi-synthetic strategies? Yeah. So I think to some extent, I won't say it's unlucky, but chemistry don't really have that good a reputation to people. In fact, if you ask me, when I go for my annual gatherings with my friends, most of all of them don't study chemistry. The only thing that remember about chemistry when they were students, whether is it O levels or A levels, right, is basically titration and mixing things, and they get some colored complexes or precipitates. They don't even call them complexes or precipitates, just say colored test tubes, or the better one will say test tubes with colored liquids. Yeah, so that's all people remember about chemistry. They never remember things like SN1, SN2, or mechanisms, or maybe in the next slide, like, how do you know that all these are true? The kinetics rate law. Yeah, but actually the bottom line I want to put it across is that all these work are being done 100 over years ago by people who simply just gets interested and they want to find out the truth about things. And of course, coming back to our topic, when these works are being done by people, they need to share with the community, right? They don't keep it to themselves because it's not helping anyone, right? So when they share it with the community, they do it through what we call publications. Yeah. So these articles are peer reviewed, meaning I send in something that I've done, and then there will be 2 or 3 referees, and then these 2 or 3 referees will be looking at my work, and then they will then think whether my work is worth publishing in the journals. They might be also repeating my experiments. Okay, I mean, in the 20th centuries, when there aren't many people sending in publication, people actually replicate the experiment and see whether it can be done. Okay, but definitely not nowadays lah. Yeah. So if they think that this particular piece of work is worth publishing in this journal, then you will get in, and then maybe after a couple of decades, when it's very established, it will go into the textbook, just like SM1, SM2. Okay, but your teacher might have told you that SM1, SM2 is just a very extreme version of two mechanisms. So I'm sure you know that they are always competing with each other. Okay, and how do people know about that? Because people have done more research and they realize. Yeah, so that's how research publication gets into part and parcel of a researcher's life. Yeah, but the general public don't really get involved themselves into all this. Yeah. Okay, yeah, so I hope that gives you a little bit of very short introduction. But before I move on, can I just trouble you, maybe to do a little bit of reflection on your own. So this particular interesting Straits Time article, you can either copy down the link, or our IT support, Mr. Alfie, will put the link on the chat group, so that you can click on it and then read it directly. Okay, so I want you to maybe spend 5 minutes to read the article quietly. I know usually I will get people, to do a bit of talking 3 or 4 minutes later, but this is not possible. We are all at home, so I assume it should be quiet. Okay, I want you to pen down your thoughts on reading this particular article. There's one more coming up. Okay, actually written by my friend, Dr. Low. He's currently the head of A-Star on one of the research departments. Okay, so you either scan the QR code, or click on his on the link, and then also read about it regarding publication, because it's actually 1 year ago he published this. He wrote this article 1 year ago. Actually, it's on whether the work should be published or not to published. Yeah, because it seems that wanting to publish is getting into the head of researcher too much. So instead of doing science properly, some people just want to publish. Of course, if you are going to do research next time, you know that publication, it's pretty important in the way you are being assessed as a competent researcher. But then yeah, you can read about it and then maybe pen down your thoughts and then share your views. Okay, so in the next 5 to 8 minutes, yep, can I trouble you these 2 articles? The first one is a Straits Time opinion article. Okay, and then the next one will be to publish or not to publish. Mr. Alfie will put the link on the chat. Yep, so you can click on it and then spend a bit of time quietly reading them. Okay, then I will come back shortly to ask maybe some of you to share. Yep. Yes, hi. I hope you have taken some time to read through those 2 links. Anyone, I mean, don't be shy, and anyone wants to share something that they have in mind regarding those things they have read? Okay. Usually the teachers, we also think that students are even more shy online, which is a bit strange, because online actually there's no one around you, right? Normally in a classroom, you are just afraid that people might laugh at you or what, right? But online, okay, anyway, just going to move on. Maybe later on, hopefully some of you will share your thoughts. The next thing I'm going to go through with you, right, will be related to publications. Okay, so now we just go straight into the stuff. okay, which is of course why we are all here for lah. Okay, but that's just a small part of it. Okay, so there's another part of it later on. Okay, but just going to go into it. It's going to be not so technical at this stage. Okay, but hopefully you will also get to experience what research publication is like. Okay, so I'm just going to share my screen now. Okay, just share my entire screen. I think it's easier for now. Okay. Okay, I hope you can see. I'm not going to go into the slide modes. Okay, I just put this very briefly. So I'm just going to give you a short tour of two very famous publications. The first one in the green bullet point will be the Journal of American Chemical Society. If you could, you can just Google that. If you could lah, yeah. If not, it's perfectly fine, because I want to run you through some stuff. Okay. Then the second one, in the pink bullet point, right, will be Angewandte Chemie in International Edition in English. That's a German publication, but it has a international edition in English. Of course, you might be interested to note that they are still publishing in German. Okay, so actually Germany is a very, very strong powerhouse in research in Europe, because I'm going to tell you a bit of the history later lah, but it came from Europe. It came from Germany. Okay, so so right now I'm just going to copy this link, okay, to here, okay, to my browser. I hope you can see the browser. Okay, it's loading. Okay, so let me know if you can't see the screen. Okay, so okay, so I'm just going to share with you. I mean, instead of me like going through, oh, like an article is ABCD, I thought that it's a lot easier if I just tell you exactly what a publication website is like and what does it entails lah. I think it helps a lot more. Okay, and sometimes if you just go into it without people telling you, it can be quite intimidating. Yeah, so maybe a little bit of introduction does help a lot lah. Okay, so this is called the Journal of American Chemical Society lah. US is, like, I mean, we like it or not, right? It's definitely one of the powerhouses in research, alongside with Europe lah. That's why I'm introducing you these two journals. Okay, one from Europe, one from US. Okay. Okay, so this is the front page. So this is one of the ACS publication, and so if you just look at it, right, this is actually just one of the many chemistry journals. Okay, how do I know? If I just click here, okay, it will show you all the ACS journals. Not sure why my internet is it's really slow today, but maybe a lot of people is trying to access it at the same time. I don't know. Yeah. Okay. So okay, sorry, I need to just go to the publication. I think it's a lot easier. Yeah. So oh right, it's here. So we are here. So you can see that they have a lot of journals. I'm definitely not going to go through every single one of them. Like, if you are interested, you just look at them. There's engineering ones, there's combinatorial chemistry, all the whatnot. Yeah. So there are a lot of the journals that Journal of, I mean American Chemical Society published. Okay, but today, for the purpose of this workshop, I'm only focusing on this particular journal called Journal of the American Chemical Society, because why am I focusing on this? For a very simple reason. It is like the journal that researchers, budding researcher, will want to publish in it, because I think, number one, it's quite prestigious to have a publication in it, and number two, it ensure that you put your footing on the research area you're at lah. But this is not the only one you can publish in lah. That's what I'm saying. Okay, you can always do in there's other avenues. Okay, but of course the most important thing I want to focus on is it is just like any other magazines lah. Okay, so it's quite complicated and intimidating at the start lah. Okay, but I just want to zoom into one little bit of things that to tell you like what exactly the page is like lah. Then when you guys are free, you can just explore on your own. Okay, I'm just going to click current issues. Don't get me wrong, you guys cannot access the publication itself. Like if you try to click the PDF, they will ask you to pay. Yeah, but you can look at the backbone. Okay, so I'm showing you the backbone now. Okay, so so this is like how the articles, how the journal will look like for this particular issue. So if you read about it over here, it's like 29 April 2020, so it's the latest one, just published yesterday. Okay, and then they tell you some stuff lah. So that's the cover. Okay, now I want you to look at these words. The word is communications. Okay, you're gonna see this term a few times today lah. Okay, communication lah. So what exactly is communication? Communication here doesn't mean you and I communicate. Okay, it just means a very short article that I want to publish in order for me to put or to establish myself in this particular area of research so that people know about me lah. Okay, and it's usually very short. So how do I know it's very short? Well, I mean, you can look at the page number. So can you see that it's about 6 pages long? Yep. So so communication is usually between 2 to 5, 6 pages long. So just basically tell people, hey, I've done this. Okay, so the Journal of American Chemical Society has a communication section. It's a pretty long section. Okay, maybe some of you might be interested. What's before that? Spotlights. Spotlights is a bit like, you know, your gossip magazine, or the magazines you've ever read, right? They are just trying to tell you, oh, you know, what's the highlight of the week? What's the highlight of this article? Like yeah. So if you read gossip magazines, you get gossipy news lah. Okay, if you read art journals, you get good news like, oh, you know, what are the main area of research? I think now the hot stuff are on COVID-19 lah. Okay, so I think I'm sure a lot of it has been mentioned. Okay, so just going to go through the main gist of it. So you have communication. It's a lot of stuff on communication. So I just browse through, I just go down slowly. So you can see some interesting titles. Yeah. See nowadays it's not easy to be a researcher also because you need to entice people to read your article. Yeah. Yeah. If you publish something very mainstream, you want to come up with some very sexy title. Like for example, this one, you see, wow, this word never used in science. What narcissistic, integrative, and kinetic cell sorting. Wow, so quite interesting. So if I'm a researcher, I thought let me click on it. See whether it's really worth the read lah. Okay, so when you click on it, what do you notice? You notice something which is the most important part of any research article. It's called the abstract. So yes, abstract is free. Okay, so you guys can go and look at all the abstract you wish to. So basically, abstract tells you, it gives you a summary of what they have done. It can be very complicated, also called chim, you know, like very difficult for you to understand certain things, but sometimes if they want to capture people's attention, they might write in a very nice manner. So over here they say what many useful principles of self-assembly have been elucidated through the studies of systems and multi-component. Okay, so I think the abstract is not very interesting. I think like quite technical stuff, but then no choice. And then if you just go down, you realize that you do get a snapshot of some stuff. Yeah, sometimes on a lucky day you do get free articles, I have to say. Sometimes on a lucky day, and especially those it's a bit like sometimes they want people to read, especially now COVID-19, people stay at home, right? So they do give quite a lot of free articles nowadays lah. But here they do. But Journal of American Chemical Society are not very explicit which article is what. Okay, let me try to click PDF. See whether I'm in a lucky day. Okay, later they might ask me to pay. Oh, lucky day today. So yeah, so you can click, etc. So yep. So if not, then you have to pay for it lah. Okay, can. So that's one area that you can you need to be aware of lah. Okay, but not to worry. If you click and they need you to pay, it's not automatic deduct from whatever lah. Okay, you still need to sign on or what. Okay, so don't worry about it. Okay, so let me just move on to the next part. Okay, I just move on and on. So yeah, a lot of interesting or not so interesting stuff lah. Okay, so let me just scroll out of the way. I'm just going to show you one more thing, and then I'm going to go back to the more interesting article journals. Okay, I'm going to go down all the way to, sorry, I think I overshot. Okay, let me move back a bit. Sorry, I think I went too fast. There's one thing I want to show you in addition. Okay, let me just find article. Okay, it's here. I went too fast. Okay, this word, articles. Okay, this is different from communication, but pretty much the same thing lah. More pages, a lot more. Okay, maybe not a lot more, but more lah. Sometimes can be as much as many as 30 and 40 pages. In this case, 10 pages. In this case, quite okay. So so what's the difference between communication and article lah? So article is like a more complete research on an area. So it's a more complete research that they have been working on. Okay, this group of researchers has been working on lah. Yeah, so it's so maybe prior to that they have published one communication, but you never know. Okay, then they cite their own communications. Yeah, this is normally the story lah. Or maybe their friend have a communication, they have a communication, then they cited each other. So usually this is how the citation sort of go up lah. But it doesn't mean when you cite more means better or what lah. Because sometimes if they manage to get a lot of reader or people manage to cite their work a lot, then maybe they'll become famous lah in that sense, because that means that their work is of some substance, some beef, and some prominence that can be gained from it. Okay, so yep, that's on Journal of American Chemical Society. Not so inspiring actually. Actually, personally, I prefer the German ones, Angewandte. Okay, so I'm just going to copy the link over. Okay, and then just going to copy this link over. Okay, so Angewandte is under Wiley. So Wiley is a publisher, quite a strong powerhouse. Yeah, indeed lah. Okay, what I like about Angewandte, right? Many reasons lah. I think number one is the way they structure their articles. Okay, I'm just going to show you an example, then you'll know what I'm talking about lah. Because I can speak until the cows come home, but without showing people examples, you might not know what I'm talking about. Okay, I just go to current issues. You notice always go to current issues, right? Yeah, because it's easiest to tell people. Yeah, because if you go to issue 1, 2, or 3, then people might ask, why issue 1? Why, well, current issue is always easiest. It's a bit non-biased lah. Okay, now, first thing you'll notice about Angew, right, is they have free access. Yeah, so the Europeans are more friendly to some extent, right? So they have free access. Not all. Okay, only the front part. The lovely pictures is free access. Okay. Anyway, what's brilliant about Angewandte, right, is that they usually have a very nice cover. Oh, in this case, this time around it's in Chinese. Oh, right. So some brilliant research by some Chinese professors, and yeah. So usually if let's say a particular research group, they want to publish something amazing, something very wonderful on this particular work, and this particular issue, they realize that, hey, your work is really worth the cover page. So they ask you to design a cover page. Then usually the professor will ask their best student to go and design a very brilliant cover page. Okay, so let's take a look. I just click. Because my hand a bit itchy. Okay, cannot click. Oh, okay. Yeah, so this is the cover page. Okay, so they have Chinese words there. So so usually they'll tell a story lah. So, okay, but anyway, I'm just going to move on. So usually the cover page will be the best article. Okay, so called lah, the best article of the issue. Then after that, I'm just going to move on first. Okay. Now, yeah, something called frontispiece, or they combine the word frontispiece. So I think I think I don't need to explain to you. That means very impactful word. Okay, so something that maybe if you look at title, it sounds boring to you. Maybe it's not something you're interested in. So just find something interesting. Okay, then so Angew for the past 15 years, they started to feature authors' profile. So those authors that publish a lot of work with them, they just showcase their profile. So they have the news. Yeah. So these are a bit gossipy. Got news, got this, got that. Yeah. Quite nice to, I mean, it's quite a nice journal. Oh, they have essays, history of science. You know my favorite, history of science. So they have that. Yeah. So if you're interested in history of science, yeah. in case you manage to get a free one, then it's good lah. Just click on it. What I love about Angil, right, is that they have mini reviews. You see, mini reviews. So how many stuff have I said already just now? Remember just now, Journal of American Chemical Society, I talk about an article, which is an established piece of work, at least 10 pages long or more. I talk about communications. Yeah. So Angil has a lot more, right? They have the front part, they show you some of the highlights, and then spotlights, and then now they are mini reviews. So what are mini reviews? Mini reviews are example where they are invited piece of work, okay, where an author of an established field, right, talk about that area that he or she does, as well as his or her competitors. So usually it's like that. So for example, let's say I'm doing SN1, SN2, then if I'm asked to write a review, then I will talk about what other people has done about SN1, SN2, something along that line. Yeah. And then you get, yeah, review is, it's something even more. Yeah. Mini review usually like what, 20-30 pages. Reviews can be 100 old pages. I've seen 100 old pages before. Yeah. So when you are, if you are a university student, right, you will love all this, because in university you get to access journal for free, right? So they are like free kind of textbook, because textbooks knowledge are old, reviews are ongoing, you see. Yeah. So they are very, very frequent kind of stuff. Some of you might be wondering, what's the difference between review and article? The difference I said just now lah. Article, it's like current piece of work. So I've just done something brilliant last week. I've managed to get it out in this week. I'm going to get it published next month. No, recent piece of work. Review is not recent piece of work. Review tends to be things you have done for the past 5 years, 2 years, and then because you are very established, people ask you to write a review on this topic, and then but you cannot keep writing on your own work, because it's not good. I mean, not saying not good, but people may sense that you are very arrogant. So don't keep writing about your own work. Also write about other people. So give acknowledgement to other people. Okay, so you can say, oh, you know, research group A has done this, research group B has done this, we have done this, and then together we establish a new field, blah blah. So that's how review works. Yeah. Okay, and then Angil also have communications, if you notice lah. Yeah, so same, they use the same terms. Okay, so communication is also stuff that 5 pages long. So if I go down all the way, what I like about Angil, I feel lah, personally, right, is they give a title. If you know what I'm trying to say. Yeah, can you see that it's, the interface is very user friendly. Yeah, so you have a communication, then they give a title. Bioorthogonal chemistry. Okay, you might not know what's bioorthogonal chemistry, doesn't matter, but doesn't matter. So they tell you hot paper. Yeah, so they are very good at marketing. They tell you hot, no, must go and read. Okay, then nitrogen reduction, they never put hot. Okay, so maybe if you are superficial, you don't quite read it. But let's say you like nitrogen reduction, okay, you'll probably go and read it lah. Supramolecular chemistry, you know, like this one, enzymes, very important paper. I also don't know how they classify all this, because I don't think they ever said. I don't think they are paid to do all this, but yeah. So if I let's say I want to set a question, for example, you know, like on enzymes, okay, very important paper, then maybe I can take a look at this particular system and understand what they're trying to do lah. Then so they classify the topics for you, which I thought is very interesting. Yeah, I mean it's like, you know, they do all the classification for you. Yeah, so it's easy for people. Next time when you go to university, if you ever do chemistry, it's also easy for you to find stuff for research. Okay, and then you move all the way to the end. Some of you might be thinking, right, is there articles here? Do Angil have articles? Yes, they do have. You see, but they don't call article, like they call it research article, but it's the same thing, like mean the same thing. So it's organocatalysis, very very important paper. So I don't know how they classify it, then blah blah blah. So it goes all the way to the end. So I'm gonna bore you the details, but this is essentially how the stuff works. Some of the very strong research papers, right, they have this interesting characteristic at the end. Okay, they don't have it here. I don't know why. They usually have some correction, like maybe we call it typo lah. Yeah, so people will go and maybe let's say I wrote a paper this week, got published next week, but a month later I realized there's typo, then I can send it figure 2 supposed to be called figure 1, not figure 2. Yeah, that kind of stuff. Okay, so yeah, this is a I hope you can see my screen now. Yeah, so this is a very short tour of two very famous publications. Okay, Journal of American Chem Society and Angewandte lah. Then I'm just going to go into presentation modes. Okay, um, in research, right, there's something. It's also a very practical thing lah. There's something called impact factor. So some of you might be wondering, should I, let's say you did something lah, then you say, oh, should I publish in Journal of American Chemical Society, or should I publish in Angewandte, or is it basically if you're European you publish in Europe, if you are in US you publish in US? No, it's not like that lah. It's more of like your comfort level, for example, then and what you truly believe in, or maybe pragmatic level, which one accepts your work lah. Okay, so you can see that impact factor is a measure of how impactful or how good the quality of the papers published over a period of time. You can see that Journal of American Chemical Society is the impact factor is about 8.1. Okay, Angew is about 6.2. It has dropped over the years actually. I also don't know why. Angew used to be way above Journal of American Chemical Society, but over the years it has dropped. But anyway, you see for yourself just now the quality of the work. And how they classify. I think it's very interesting. You notice that all the reviews, chemical review, Chem Society reviews, account of chemical research is also review. Review papers usually, okay, these journals are journals that only have review papers lah. Which means if you did some work, you cannot publish there because they only do reviews. And reviews usually have very high impact factor because they have a lot of citation. One of the ways people measure the quality of the research the journal article is by looking at citations. So you can see the citation of a review paper is very high because people will cite their work because they are like the textbook examples of what we are doing. Okay, and then you might have seen this Nature. Okay, yeah, Nature is a very strong, very powerful, prestigious organization that publish very good work as well. So if you have a work in Nature, means you are quite good, very good. As in Nature, just Nature. Okay. Then they are branched out into a lot of areas called Nature Chemistry, Nature Materials, all the nonsense, right? Basically, it's just about, it's sort of money making lah. Okay. If you read about the second article that you saw just now from my friend, right? Actually, paper is a very good money making business for them because they generate a lot of revenues. Can I also bring to all of your attention, there is a journal by Nature that is free to access for everybody. This is the one, Nature Communication. Yeah, but it's not only chemistry lah. It is all area of sciences. Okay, so if you are interested, you can just go to Nature Communications. You get free access regardless of where you come from. Okay. Okay. If you could maybe spend like 3 or 4 minutes on, okay, maybe that's too short, 5 minutes lah. Can you go into the article, the shared drive, right? It contains 10 articles. Okay, I've numbered them purposely because I just want to give you an example of what exactly is communication, what exactly is a full paper, what exactly is a review, and then I have a category called others. So maybe let me explain to you what is others. Okay, can I exit first? Okay, I hope you can see this. I hope I'm still on presentation mode. Oh yeah, I'm still on presentation mode. Okay. Okay, before you spend that 5 minutes, can I just bring to your attention 3 very important things lah. Okay, just 3 things. Just listen to me for a short while more before you go for your break. Okay, I think it's about 5, and then you can start to browse through some of the items in the folder. Okay, just give me that 5 minutes. I just want to complete what I want to tell you. This is exactly the same thing that you see in your folder. Okay, so you have a lot of stuff. Okay, I have added one interesting thing inside, interesting piece of article inside lah. If you just click on it, right, it's by Professor Whiteside. It's a very famous professor from Harvard. He writes about how to actually write a paper lah. Okay. Okay. Why do I give you this lah? Because I do foresee that in the future, right, most of you will or might be related in research one way or another if you are decided to pursue this kind of the discipline. This is a very important this is not a research paper, this is just opinions. Because basically at the end of the day, right, when you write papers, right, you want people to read. So how you may have done fantastic work and it gets published, no problem, because the work is quality. But if it's written in such a way that you don't feel like reading it, or people don't feel like reading it, then it's very wasted. Yeah. So actually, writing a paper is a skill, which of course we are not teaching you here lah, because you have to do research first before you can start to tell people about your brilliant work. Yeah. So writing paper is a skill. It's not just a report of what you have done, but more of how you want to enthuse people, how you want to get people to buy your story, and then how you want to get people to read the next part of your story. It's like part 1, part 2, part 3 of your work lah. So yeah, it may be published in Nature, Science, but if the work is not readable, then nobody will read it lah. Okay, so that's that I thought I just want to include this interesting piece of article for you. There's one more thing I want to introduce to you. Remember I said 3 things, right, before we go for the break, right? So the first thing was that. The second thing was article number 5 actually. So article number 5 is a brilliant piece of work by okay, this is a Nobel winning piece of work, but this group of people didn't win the Nobel Prize. 2 or 3 years ago, the Nobel Prize was given to molecular machines. Okay, maybe let me open the review article. Article 4 is actually the review article. Artificial molecular machines. So this is the review article by Professor Stoddard's. Professor Stoddard's work on molecular machines. So this is the guy, Professor Fraser Stoddard's. Yeah. I won't go into it because it's a lot of stuff. So basically, they are using molecules. So they make huge supramolecular system, right, to mimic objects, okay, like a mechanical lever, yeah, using Van der Waals forces, etc. So if you're interested, you can read about it. It's a Nobel winning piece of work. He worked for 30 years. Yeah, Professor Stoddard won the Nobel Prize. Yeah, so this other research group, probably some of them are his students, right? Former students, right? They actually came out with this interesting piece of work called a reversible unidirectional molecular rotary motor driven by chemical energy. The title don't sound very inspiring because it sounds very chim lah. Okay. Then after that, you read if you go and read the preamble of the abstract. With the long-term goal of producing nanometer scale machines, we describe here the directional motion of a synthetic molecular structure fueled by chemical conversion, etc. Like, it's very kind of dry, and then yeah. But this piece of work, not okay. Before you get me wrong, I'm not criticizing the work, as in, because this piece of work is published in Science. Look here, Science, very prestigious, impact factor easily way above Journal of American Chemical Society and NGU. Yeah, it's just that as what the first link I showed you just now, right? People don't understand. Like the layman on the street, pass this to your parents. Like, okay, don't talk about parents. Like, let's say you guys, let's pass it to you. If you read through, how much of it could you really understand? So you have a brilliant diagram here, etc., right? Yeah, so now you have some molecules. So it's like very condensed piece of work that not many people can appreciate and understand. Like when you do a research, you want people to get it, right? If you do something people don't get it, then then what's the point, you know? Like, okay, so okay, I mean, I haven't finished my story, so there's a third point I want to bring up. So what happened was, um the research article, they are quite smart also. So they know that, hey, like, I want to improve my readership. So Science, as a magazine, right, they came out with this idea called like spotlight, or like, okay, my language, I call it teasers lah. I call it teaser. You can see that I classify this as teaser to article. So a teaser, it's like, um give you a snapshot about what they did, but not the chemistry. Okay, so you can see I give you the teaser. So they changed the title, inventing a nanomolecular wheel, and then yeah, you can read about it. It's a lot more readable, I guess, the teaser, and no chemical structures, just English, right? But it's still a lot of words lah, I would say. Yeah. So these are the teaser. If you want, you can just browse through it, and then you see whether this piece of work is worth reading, etc. Yeah. And before you go on your break, I just want to tell you something. This is a great gift I can have for you. Actually, this two article, 5 and the teaser. Okay, because I just want to share with you lah. That this was the paper used by Raffles, right, last year for their stimulus-based question. It's the exact same paper. Yeah, I just want to share with you. Like, actually, in H3, there's a component called stimulus-based question, right? And usually it's based on an article or two, and but don't worry, things are not from the actual article. Maybe they are from the teaser. So if you ever have access to the RJ question, you can ask your teachers. I'm sure they have access to that. Stimulus-based question, Raffles 2019 prelim. Yep. This is the exact article they use. Try to answer some of the questions if you could get hold of it. Okay, but of course, the abstract they use is a much condensed version. But I just want to share with you that for stimulus-based questions, usually people take ideas from contemporary research. Okay, yeah. That's all from me for now. Is there any questions you might have? I'm sorry for talking for so long. Yeah. Before you go on your break, and then remember that when you go on your break, please browse through the folder, look at some of the articles, and maybe if you could jot down one or two of your thoughts on which of the articles you will really go and read. Yeah. Okay, then yep. So I think we'll take 10 minutes break. All right. I'll come back 5:15. I mean, yeah, you can sit at the computer, or you can just go to the ladies or gents, and yeah. Then we'll come back at 5:15. We'll continue a little bit more, and then before we maybe break up for some activities. Yeah. Yeah. Hi. I hope you have explored the link, the Google Drive, and some of the stuff that we have in the Google Drive lah. So I'm looking at the Google Drive now. Okay, I'm not presenting yet, but I'm just looking at the Google Drive now. So there is actually a worksheet, but we'll deal with it later. Okay, not now. So before I move on, I just want to share two more things with you. Okay, just two more things with you, because if you have seen through the folder, then you might be wondering about some stuff lah. Okay, so I thought I just want to share this with you so that you are clear. Okay, so far, right, we have been talking about review papers, research articles. What else have we been talking about? Communications, and then maybe a little bit of teaser to get people to want to read the papers, etc. Right? Yeah. There are actually another kind of papers that we can't really classify them, and these are really interesting stuff lah. Actually very interesting for teaching and learning purposes, especially for students. Okay, I'm just going to share with you what you'll be getting. Okay, let me just share the screen with you in its entirety, so that it's easier. Okay, I'm just going to show you this. Okay, just give me a while. Okay, now if you have seen Article 3, you realize that it doesn't fall into any other category. Am I right to say that? Yeah, it's actually something that is very weird because it's actually a conversation between um three very famous chemists actually. Yeah, of which two of them are Nobel laureates. I'm not sure about the first one. Yeah, maybe he is as well. Yeah, Hoffman. Yeah. Okay. So yeah, I mean sometimes people will just want to write or rather very established scientists will just want to write something that to enthuse young and budding scientists, and maybe at the same time to showcase some of their opinions on certain issues. Yeah, so I thought this is a very nice article to share with you guys, especially you guys have learned, or either you have learned or will be going to learn molecular orbital theory. Okay, so one molecule, two atoms, three views, four bonds. Okay, so take a look at it. Um, okay, it might contain things that are not exactly very relevant in the curriculum. I would say definitely they do contain stuff that are not very relevant. But not to worry because I think it's always okay to learn a little bit more, and you can always find out more from reading beyond what you need. Okay. The final thing I want to share with you on this folder is actually on this interesting similar story, similar kind of storyline, conceptual disorder. um I always I always find an extremely great joy to share this with my students in my H2 classes. It's regarding entropy. So yes, again written by a very established professor who teaches entropy. So if you read through the whole article, I think I assure you that you will have a new view of entropy. It's a view that you never knew even existed, um, for the past 1.5 years. Okay, so I do appreciate if you can look at it and then think of it. Just look at it and then see what you can gain from it. Okay, so this is an article that I thought is really interesting. But they don't fall into any category. That's the point I'm trying to say. They are not like review papers. They are not like research papers. They are just views. Like yeah, yeah. So yep, something that is good for you to be aware of. Okay, so yep, I classify them as others. Okay, now the boring thing is this kind of workshop cannot run away from going through how do you actually appreciate reading an article, right? So I need to tell you that a research article has a backbone, that goes something like abstract, introduction, methods, results, discussion. It's kind of boring if I like tell you that, but I have to tell you this. But don't worry, I'm not going to bore you with the details because I think a lot of it I've already kind of like tell you bits and pieces here and there lah. But I just want to formally introduce you to the fact that a research article has sort of this kind of thing as a backbone lah. Okay, but instead of showing you this, right, I thought that I want to go into how do you appreciate the work of others lah, um, or how do you know that it is for you lah. So there are some big questions you can always ask yourself lah. Should I read the abstract first or should I read the introduction first? Yeah, if you get one. Okay, later I'm just run you through with one example, then you know what I'm talking about. What is the big picture? Is it worth my time reading it? I mean, your time as a researcher in the future is very limited. Are you going to read every single article? No, right? Yeah. How are you going to get into? So normally people read about work that they are interested in lah. Yeah. Let's say if you are interested in let's say photochem is something else, but let's say molecular machines, for example. Just want to talk about molecular machines, right? If you're interested in molecular machines, then yeah, maybe you can talk about read about molecular machines. And so do you read every single articles on molecular machines? Do you do that? No, I mean we don't do that. Like do you read from all journals? Just now I'm only showing you 2 journals, Yeah, within each publisher there are millions of not millions, but there are hundreds of other journals. Do you read all or no? Or are you selective? Yeah. So yeah, how do you choose? So what's the big picture? What are they doing? So where is the beef? What exactly are they, or what did they set out to achieve. Yeah, so this might be a little bit more useful to you rather than the backbone, like abstract, introduction, etc. So with that, I'm going to give you an example. Okay, I will use the same example as the worksheet in the folder. Okay, so if you want, you can just click on the article, and if you want, you can just follow me through. Okay, this is on Angil. It's an article on Angil, published some years ago. Okay, yep. So and as I mentioned, Angil usually like to show people the title. So I think first of all, when you go to the Angil website, just now we did that, right? When you browse through, right? Are you someone who is interested in natural product synthesis? Okay, if you're interested, just click. Okay, and of course you read the abstract first, lah. Like, does the abstract into this one? They don't have the abstract entirely here. Okay, the abstract is actually somewhere else. Okay, but for this case, they can read the introduction. You can read the introduction if you want, lah. Yeah. So normally, for students, right, for you all, you might not be able to gain extremely big insights from the title or what, but you can gain some insights into the introduction, from the introduction. Okay, why do I say that, lah? The reason is this. I'm just going to ensure that okay, if you read the introduction, just list one little paragraph here, right? They are kind of trying to tell you something about the importance of making natural product, lah. So if you read, like, development of shorter genetic sequences for the synthesis of complex blah 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 represents significant progress in synthetic organic chemistry. Considering this, the development of a method capable of initially providing the core structure of a target molecule, followed by stereoregional chemoselective introduction of functional groups as a desired position, blah blah, and then blah blah. Okay, so they wrote a whole big chunk of sentence, lah. So normally, correct me if I'm wrong, lah. If you go into any research papers on natural product synthesis, the starting point will usually be something like that. Usually, yeah. To y'all now, it's very refreshing, lah. Okay, but if you have read it long enough, you know that they always tell you something amazing about why must people do that, and find some reason for them. Like, people need to find reasons why. I mean, they need to tell people, hey, I'm doing this because I'm able to do much more, yeah. So it's important. But making this kind of motherhood statement or very grand statement, right, actually doesn't help much. As in, you don't really introduce people much into what you're doing. So normally, right, there is always another paragraph coming in, which is here, and this particular paragraph, right, they kind of introduce you a little bit about why do they choose to make certain molecule that they choose to make. Okay, then you'll ask me, so all chemistry research make molecules? No, not really. Yeah, I think I told you just now, right? This one confirm make molecules, because this one research is on natural product synthesis, so confirm make molecules. What did they make? Trichodermatides A. So that's what they make. Okay, so this one confirm make, but not all make. Okay, some maybe do other stuff. Okay, so this time, so this one they confirm make molecules, but they need to tell people why are they making it, right? So they need to tell you some stories. They say, like, someone has elucidated the structures, and then most importantly, right, I think this statement is important, especially those of you who wants to go into bio or even medical field, right? Establish their cytotoxicity against the A375S2 human myeloma cell line. Those of you who did bio, you know this means cancer. But actually, to be honest, any natural product, they are anti-cancer to some extent also, lah. Okay, so that's not very inspiring, but yeah. But anyway, inspiring enough for them to publish and work on some stuff, lah. So usually, if you want to work on some natural product synthesis, right, you must somehow show that it's sort of anti-cancer, lah. Okay, so they wrote a lot of stuff, lah, and then they try to tell you how difficult it is to make this. They say, the oxygenated pentacyclic means got 5 ring combined together, got 8 chiral center, and then they will usually spin a beautiful story telling you, it's damn difficult to make this. So we have done it. Please let us publish in this journal, something along that line, but that's really indirect. And then usually they show you some of the strategies, which usually I think when students look at it, it doesn't sound very interesting. It's just some strategies they use lah. Okay, so usually journals are like divided into 2 pages, so you can read the other side. Okay, so basically here they tell you, okay, from this molecule they make this and then blah 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 blah, and then after that, yeah. So normally when you are reading or when you try to decide whether an article is for you to read or not for you to read, right, you will normally just browse through this part, and then you ask yourself lah, worth reading or not? Is it interesting? Is it a strategy that I can use in my own work, or is it something I just read for interest? Yeah. So if it's none of those, then you don't read lah. Then if it's interested, then you can read on. But maybe before you read on, you can go to the conclusion lah. Sometimes going to conclusion is quite helpful to see whether is it worth reading after all lah. So actually here the thing about Angewandte paper is that they don't really have a very clear cut like results, discussion, conclusion, but they have this in summary. We have described, okay, so you can read lah. Oh, so they have done the first synthesis of this amazing molecule called trichodermatide A, and then involve a sequence of, oh, so they started with L-tartaric acid. Wow. Okay, then you need to ask yourself, why do they need to start with L-tartaric acid? And then they went on to say, oh, you know, like, oh, this highly efficient intramolecular ketone formation reaction furnishes the pentocyclic. Okay, so they basically sort of reiterated the amazing things that they have done, the amazing chemistry that they have done in order to make this go into Angewandte as a publication. If all this amaze you and you feel that, oh, okay, I think it's worth reading, then you can actually, as a student, right, I mean in the future lah, as a research student, for example, let's say you're doing all this research, you can move on to read about the other stuff lah. Yeah, like the rest are all the details lah, and then all the reaction scheme, blah 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 over here. Okay, so essentially it's the same as you reading a magazine. Yeah, Times Magazine, for example, you don't read from page 1 to 100. You read articles that are interesting to you lah. Yeah, the thing about Times Magazine or even National Geographic or even those entertainment magazines, right? The thing about them is they are usually quite straightforward. Meaning, what do I mean by straightforward? They usually just have pictures and words lah. So normally human look at the pictures, interesting or not? Wow, the National Geographic got a tiger, or they got Iceland photos, or nowadays is about what global warming. All this title interests you, then you go and read those articles, right? Like Times Magazine, you read about back then is Trump who won the US election. Maybe now for this year the key news is whether they're going to carry out election in November. You know, like all those very sensational news that people like to read then you go and read. Research article, the thing about it is it's not so interesting in that sense per se not so interesting yeah, because it is field dependent, you see. You know what I mean? Like for example, right, you know, an entertainment magazine, you can read anything you want. Like there is no, you don't really need prior knowledge. Okay, maybe if you are reading about what all the entertainment gossipy news, you might want to have some, or you might need to have some prior knowledge to why this thing happens the way it is, but it's not essential, you see. Yeah, and let's say you don't want to read this news, you go and read about something else, maybe about US election, maybe Times Magazine, you read about global warming. If you are not so interested in about global warming, but you want to read about global warming, you can read about it and you will understand what is going on. You get my point? Yeah, but research articles is not, the barrier is not so small. The barrier is actually very huge. Yeah, if you just recall what I did just now lah, I don't know whether yeah, so for example, the barrier is not like, for example, this is Angew, right? Like for example, if, okay, let's say we talk about fluorescence. If you have no knowledge about fluorescence, right, you cannot read this article at all. You get my point? When you read about it, well, I mean, you can learn about it, but the barrier is still there. Yes. And if you don't know anything about porous materials, so research article always have this barrier. If you are not in this field of research, right, there is this very huge inertia to prevent you from reading it. Maybe I put it that way. Very few people read across all fields. Very few that I know. Yeah. If they do, which means there are people who are genuinely interested in the subject discipline lah. Like they like to read almost everything reading outside their comfort zone. Yeah. So you guys need to understand that reading research article is different from reading entertainment news or Newsweek or Times. It's a bit different. Yeah. It's not like I want to read Times, I can read page 100 easily and you understand. Research is article is different. You may want to read about a quantum mechanical interpretation of, let's say, quadruple bonding, and you open it out and it contains all the math, and then you just close it off and say this is not for me kind of. Yeah. Then if you are not the type that likes to read organic chemistry, like let's say you are physical chemistry fanatics and you look at molecules like this, it will just throw you off. Then you won't be reading this. Yeah, you will probably be looking at all the equations and try to formulate maybe a simpler way to do simulation studies. That's what people normally will do. They will read things according to what they like. But for you guys, it's different, you see, because you are doing H3 Chem, which is related to organic chemistry quite a bit. So whether you like it or not, maybe I put it explicitly, right? It might be good if you can absorb some of this knowledge that I have shared with you, at least so far on how to read articles and maybe on all these articles. Okay, so I think I've spoken enough. Um, Perhaps maybe in the next 10 minutes or so, can I just get you guys to maybe spend a bit of time exploring the article 2 especially? Could you all do that? Maybe you spend a bit of time exploring article 2. Exploring meaning just read through them, and if you want, you can go to the folder, Google folder. Let me see where the Google folder is. Yeah, go to the Google folder, and then if you could open up the folder on. Let me. I'm trying to open up. I'm trying to find where it is. Yes, it's here. Yeah. Open up this. Yeah. A little bit exercise on article 2. Yeah. Yeah. So basically, I have just sneakingly inserted some potential H3 question that you might get from the article on this trichodermatite. Okay, so we have some mechanism questions here, and then some, yeah, just very short one lah. Then some appreciation question like why tartaric acid is used as a starting material to synthesize 12, like why is PTS a stronger acid than PTS given the structural formula, etc. Okay, so maybe you guys can take like 12, maybe 10 minutes to look through it, and then I think at about 5:45 I will just come back here, and then yeah, do a rounding up, and then that's it. Yep. And then yeah, I think it's good to spend a bit of time to look through the article briefly lah before we end the workshop. Yep. Okay, so yeah, I will be back at 5:45. In the meantime, focus on reading the article a little bit. Just try to get the gist of it lah. We're really not expecting you guys to understand every single bit of it. Yeah. But before, yeah, just go ahead and read it. But in case some of you have questions, is there any questions you have for me at this stage? Anyone wants to ask me questions? Just turn on your mic and then ask, maybe like a question on reading articles, etc. Okay, if not, yeah, just spend 10 minutes silence time. I'll come back at 5:45. Maybe if you have questions, you can ask me at 5:45. Yep. Okay. Okay. Hi. I guess you might have briefly read through the article, and then I mean just at least at the start, and then probably have a little bit of time to maybe even look at the first question lah. Okay. So I'm not going to because definitely this thing will end very soon. I'm not going to hold on to your time and then move on to talk about a lot of things that not exactly the purpose of this workshop. But I thought that um, you get to see the opportunity of looking at a chemical literature and then realize that a lot of the reactions that you have learned in your H2 and H3, right, are actually entirely relevant. So this will be an example that I'm going to give you. So let me share my screen first. Yeah, just very quickly, I'm just going to give you a very quick examples that then you will know what I'm talking about. Yeah. Okay, so remember that I hope you can see my screen now. Remember that we talked about 12 giving me 5. Okay, and then you were told about this piperidine being a strong, or rather being a base. Okay, so if you look at it, let me just share this with you. Yeah, sorry, I need to share this. The whole thing is a little bit easier, right? Yeah. Yeah, just because if you look at the question, right, it was mentioned that piperidine is actually a base. So I think you can easily tell that because your nitrogen has a lone pair of electrons and it's a secondary amine lah. Okay, but what has a base got to do with the mechanism going from 12 to 5, and what is the purpose of this? So and how is it linked to H2 and H3? That's probably something that you might even be wondering, right? So in the very short remaining time, right, I thought that I can just use this very simple example to show you. Okay, so this is the molecule that is drawn for you. You realize that that you have an alpha proton, right, or this particular H, right, that is actually flanked by 2 highly electron withdrawing group. So if you recall from your H3 or even distantly related, which is H2, right, you learn that if you have a base and you are next to a and you are being added to a carbonyl, and especially in this kind of case where your proton is flanked by 2 highly electron withdrawing group, right, it will make it extremely acidic. So that means that some form of acid-base neutralization will take place. So when I'm not going to draw for you the mechanism, but just basically kind of for you to see that if an acid-base neutralization takes place, right, then I'm going to get a nucleophile, right? Can you see this is a nucleophile? Okay, and this particular nucleophile, and if you notice there's a aldehyde here, okay, it's going to perform a very simple reaction which we have learned in H2, which is nucleophilic addition. Yeah, so it's going to do a nucleophilic addition here. Yeah, so basically having a knowledge of H3, right, and being able to appreciate a research paper a little bit, right, allows you to kind of like engage yourself into this kind of discussion, like, hey, what's the mechanism? What do you think it's like? Oh, okay, so maybe piperidine is a base, it undergoes acid base with this particular ketone and then generates a nucleophile, and then the nucleophile undergo a nucleophilic addition on this aldehyde for the first step, right? Like first step nucleophilic addition. Later on then talk. Okay, as in we don't have to stress ourselves over a lot of stuff. Okay, and you realize that the whole story actually makes sense already, because if you look at this, right, this thing is actually looks like this, and this thing also looks like this. So actually, right, this whole reaction from 12 to 5, right, it just undergoes a series of addition, elimination, and perhaps some form of a condensation along the way. Okay, you don't have to draw the mechanism straight away. I'm just saying that it gives you that sense that a little bit of, maybe I can say it's a security lah, that actually I'm aware how to draw the mechanism. I can do a bit of discussion. Yeah, but to draw out in its entirety, maybe it's a bit challenging. Maybe it takes a bit of time. That's fine. Okay, so that's the whole purpose of the particular worksheet for you. It's basically just to give you a glimpse on the kind of opportunities that can be open to you when you learn H3, and then if you understand a little bit about research articles, how to appreciate it, and then slowly but surely you will be able to better engage yourself in understanding some of this seemingly difficult stuff, but it's definitely within your capability. Okay, yeah, that's pretty much what I want to share with you for today. Is there any questions you might have? Any last questions you might want anyone of you ask me? Because I think throughout the whole session, right, I only hear two voices. Actually three voices lah. My voice, Dr. Chan's voice, and then Mr. Lee's voice. The rest of you, anything you have in mind, or any questions you have for me? If not, then for the final thing that I want, or I hope that y'all can help, which is actually for your juniors lah, is could you go to the chat and click on the link to the survey? Yeah, because the workshop that you are experiencing today is really from the feedback that your seniors gave last year. Yeah, so like exactly what is useful and what is not so useful for the students, and of course we do take the feedback very seriously, and at the end of the day, we I hope that whatever that we are doing here can help you in your journey. Okay, so please let us have your feedback, including the teachers who are also listening, because of course your feedback is also very important for us to I mean, as a family, all the H3, because H3, although we are from different schools, including students, but it's a very small community lah. So together we help each other, and hopefully we will all gain from it. And let me take this opportunity to maybe wish all of you good health and safety. And I would say you guys are a very resilient group of people. Despite the ongoing crisis, you are still hanging on to H3. Maybe can I also say one final thing? Please don't drop your H3, because I think you are a batch that is worth remembering lah. And I'm sure you will do wonderful. Yeah. Okay. If you have further questions, you can just drop me an email on the first page. I will just upload my slides there later on. If not, then have a great weekend. I know it's one day short of your well-deserved holiday, although it's not exactly a holiday, but yeah, I hope you can find some rest and learn some new skills. Okay, yeah, that's all from me. Yeah, have a good weekend. Yep.